welcome to my YouTube channel, and today we're going to look at pure physics. Yes, pure physics. Today we're going to do pure physics, and the question we're going to do is question number 2, 2015. The question, mainly the topic is how to calculate the reaction time using a graph, given a graph. It can be given in another form, in a theory form, or in a graph form. But in our case, we have the graph. That's what I'm going to do with today. So we're going to solve question 1a. Question 1a reads as this: calculate the distance during the reaction time. So our aim is to calculate the distance during the reaction time. So how do we do that? The formula for the reaction time is equal to dr, which stands for reaction time, dt. Sorry for that, dt. Yeah, or dr or dt is okay. Or drt, for in short, drt stands for during the reaction time. So the formula is equal to speed times time. So I calculate speed times time. So data is very important. Correct the data using the diagram. So speed have been given here is what? 30 meters per second. That's our speed. 30 meters per second. Then our time. So how do we find our time? When you find in time, you have to start from 0 up to where the reaction started. From 0 up to where the reaction started. So if you look at this diagram here, the reaction from 0, it started or the driver applied the brakes at 1 second. That's our time at 1 second. Because that's when the driver applied the brakes. 1 second. Then you have to try to do just go back again to the same formula saying dRt is equals to speed times time. Also our speed is 30 meters per second multiplied by our time is what? 1 second. So our answer will be 30 meters. You say therefore the dRt during the reaction time is equals to the distance moved during the reaction time is 30 meters. Sorry, fine right there. The units cancel since they are multiplying this. It's a fraction. That's how you cancel this. AC you cancel with that S over there to remain with meters. That's your distance during the reaction time. So the key lesson here is you have to understand that the reaction time is equal to speed times time. And how do you correct the time? Is by getting how long the driver arrives or went into action from where the event started until the time where he applied the brakes. So here the event started at 0, then he applied the brakes at 1 second. That's how we got the time as 1 second. Yes. Then we'll go to question B. Question B reads: find the deceleration of the bus. Simple. That shows the same formula for finding acceleration, which is acceleration is equal to final velocity minus initial velocity over time taken. Again, data. Always correct data. So here our data, we need what? We need our final velocity. And if you look at the diagram here, our final velocity is here, where the line is touching down. The reason why this is a final velocity is because we're dealing with deceleration, meaning that the phase shall be last. That's the best way I can explain it. If you know the normal formula for acceleration, which means the final velocity should be 30 if you're using if a car was acceleration. But since it's going the other way around, which means that here it will be the final velocity, which is 0 meters per second. And our initial, it will be 30 meters per second. Just like that. Then our time. So how do we find our time? You simply look at the diagram right here. After looking at the diagram, where it's starting from here, where the deceleration started here, and where the deceleration ended, you subtract, meaning that time to be equal to 3 seconds minus 1 second, which will give us 2 seconds. Like I said, time is equals to 3 seconds minus 1 second, which will give us 2 seconds. So therefore, our time taken is equals to 2 seconds. Just like that. Then you go back to the formula given. Deceleration, you introduce a negative saying that is deceleration. If it's positive, just put a positive, which means it's acceleration. But it's negative, it means retardation or deceleration. So it's equal to our final velocity found is what? 0 minus our initial velocity z. We can factorize the units to give us meters per second squared over the time we found there is what? 2 seconds. Continue simplifying down there, you remain with negative 30 meters per second. Divide by 2 seconds, and your answer will be negative 15 meters per second squared. Since we're dealing with acceleration, it will be squared. So our retardation is equal to negative 15 meters per second squared. Just like that. Then you go to question C. Question C reads, determine the force provided by the brakes if the average mass of the bus was 1,600 kg. So now I have to determine the force provided by the brakes. Okay, so again we're going to say data mass have been given in the question, which is 1,600 kg. Then our retardation which is equals to 15 meters per second squared. Now force, we don't know. So here what we can use, just use the general formula for finding force, which is force is equals to mass times acceleration. Continue saying force is equal to our mass is 1,600 multiplied by our retardation, which is 15. So the force applied, it was when you multiply on a calculator right there, when you say 1,600 multiplied by 15 to give us 24 or 2,400 newtons. Yeah, 2,400 newtons. It will be 2,400 newton. So therefore, the force applied was 2,400 newtons. That's your answer. That's how you answer in an examination class if you're dealing with the reaction time. Thank you for watching Mtandi TV. Don't forget to like and subscribe to my channel.